Awesome. Okay, so when you were just now squishing your bottles that you fill with a slight bit of warm water, and they're not cloudy, you squish them, you observe that they're not cloudy. When you take your bottle, our Chris's, and you look at it, and then you crush in on it, what changes about the bottle? The size of the bottle. So we measure size of a bottle in volume, right? In liters. So the volume of the bottle changed how when I squished it?
Decreased.
The volume decreased. Now, did the amount of gas inside the bottle decrease? No, the lid's on. Hopefully no gas can get in, no gas can get out. So we have the same amount of gas, but less space for it. So what happens?
Compresses.
The gas gets compressed in the bottle, right? I let loose, it can expand again. I squish, I let it loose, it can expand. So does energy get added to the system when I squish or let it expand?
Squish.
Maybe. But when I let it expand, there's no heat change, is the point I'm trying to make. There's no heat change. I don't have a burner. I'm not adding heat to the system, right? So when I let it loose, it expands, but there's no heat change. So why don't we see a cloud form? Because we're giving it the exact conditions of adiabatic cooling. We allow it to expand with no heat change, but yet no cloud form. So why is that, Joseph?
Because there's nothing for it to condense on.
Nothing for the water to condense on. So, how is a cloud formed? Why does it need something to condense on?
Because it does.
Okay, because it does. So, when I compress, we've got water vapor and other gases in this bottle. They're compressed, they're under pressure. When they're allowed to expand, right, they cool because there's no heat added to the system and expansion causes them to cool. So when they cool off, some of them lose enough energy that they go from being a gas to being a liquid. But if there's nothing for them to condense on, then they just can't condense. Kind of like water can't evaporate at 100% humidity. Water vapor can't condense if there's nothing for it to condense on. Clouds need what we call cloud condensation nuclei to condense upon, little particles of tiny dust or other chemicals that are solid that, or other liquids like another water droplet can allow more water to condense upon it. So we're going to provide some dust or debris in the air using a match. So each team or person is going to just light a match, blow it out, and drop it in to their bottle once it's blown out. Drop it in burning. Blow it out, put it in, and put your lid on quickly. And then the smoke from the match will provide dust and debris for the water vapor to condense on when it expands and cools because of the expansion. So we're going to take off your lid. We'll come around. We'll drop your match in. So, I've already entered enough. Blow it out, put it in, put your lid. Hopefully we've got some smoke in there. Now,